So these are the equations we have to play with. Is there nothing about the conservation of mechanical energy?
No.
Okay. But the conservation of mechanical energy says that the total, so this one is not on there. The total mechanical energy equals the kinetic energy plus the potential energy. Okay. So let's go to I think I worked through all the little net work, conservative work, non-conservative work, all those equations during the lesson this morning. So now, I think we can do, on that worksheet, we were on the point of, at the point of working through some examples there. What do we have? We've done that. I think we're with the examples on the second page. I think we've done all these. This one we did earlier in the class. So we're on example 1 on page 2. Okay, now I don't have it open, so you need to tell me what is happening. Example 1 on page 2. Who's going to inform me of the situation?
Nalo. A child pushes a toy with a horizontal force of 5 newtons.
So can I reduce the toy to a dot and say there's an applied force of 5 newtons?
Yes.
Okay.
Distance of 2 meters. The toy mass is. Where are we? Example. The toy mass is 100 grams, so 0.1 kg. Initially at rest.
So the initial velocity is 0 meters per second. So this tells me that there's going to be a change in kinetic energy. That's what this is telling me.
Accept that no work is done against friction. Calculate work done on the toy car.
Okay. So what is the work done on the toy car? There is no friction. Will the FG do any work on the car? No. Will the normal force do any work on the car? No. Okay. So the only force that we know of that's acting on the car, that's doing work on the car, is F applied. So there's no debate about it. Okay? So W F applied equals WF delta X cos theta. This is easy. I don't want to bore you. Can you see that it's easy?
Yeah.
Okay? So it's 5 times 2 cos 0. So that is 10 joules. Okay. What's the second part of the question? The final kinetic energy, not the final velocity, the final kinetic energy. Okay. Can I use this equation to calculate the final kinetic energy? No. Can I use this equation to calculate the kinetic energy?
Yes.
Why not? Because the change in potential energy will be 0. Can you see that? Is just moving along a horizontal floor. So is it going to go higher up or lower down? No. So it is possible that I can use this equation because it's got change in potential, change in potential and change in kinetic energy. But there is a simpler way to do it. Can I use this equation to get the final kinetic energy?
Yes.
Okay. So with the initial kinetic energy being 0, and with understanding that this applied force is also the net force, because there is no friction. They said we don't have to look at friction. Friction will oppose the motion. So this child is playing on a very smooth surface with this car. So they're ignoring friction. So the F net would be equal to F applied. That's how I understand it. So the work done by the applied force is the same as the work done by the net force. I'm just writing this down for myself.
Can I write
Yeah. Are you with me? Yes. And now I know that W net is equal to the change in kinetic energy. Okay? And the change in kinetic energy is the final kinetic energy minus the initial kinetic energy. And what is the initial kinetic energy?
0.
0. Because it was stationary. So what is the final kinetic energy? It would be 10 joules. Isn't it 10 joules?
Yes.
Okay. I'm not sure. Does that question ask you for the velocity? Oh, my.
Yes, it does.
It does. Yeah. So I'm taking baby steps here. That's why it's going so slow. So this is 10. Then the final kinetic energy is 10 joules. Now, they're asking us for the final velocity. What equation shall we use for the final velocity? This one. Okay. So EK equals a half mv squared. That's 10. This is a half. You told me this is 0.1. What is V? Sorry, this is going off the screen now.
No, stop.
Oh, look.
Just stop. Let me get it.
They like to manipulate you, don't they? You have to do all the reading, but you have to wait as well.
No. 14.14. Yeah, that's also what I got.
And the unit is meters per second. Please don't throw units away. Fortunately, I won't see your papers at the end of the year. Fortunately. Such an embarrassment if children throw the units away.
Are you going to see
What are you eating today?
our prelim paper?
Yeah, I have to mold it. Alright? I'm going to hold it to clear the board. Yes. If they say use the work energy theorem, they restrict you to the path that you must take. Then you've got to take W net is delta EK. Okay, Lipero, what is the situation?
Oh, you want me to read it?
Yes, please.
Use the work energy theorem to determine the speed of the object. Mass 40 kilograms, pulled across a rough horizontal surface by a force of 250 meters. acting at an angle of 30 degrees to the horizontal. The resultant displacement is 20 meters along the surface, and the friction between the object and the surface is 30 meters. Assume that the object started from rest. Initial example 5.
Oh, now I see why you say we've done this already. Because it sounds familiar to me. But we did it in a different way. So is it a flat surface, a horizontal surface? Okay. So it's an horizontal surface. The applied force is 250 newtons. Is it at an angle?
Yes.
Oh, we did this. Of 30 degrees.
But I think in the example they didn't say use the work energy theorem. Okay. And the friction is this 30 newtons. We've got a gravitational force obviously, and there will be a normal force, but because their angles to the horizontal is 90 degrees, they will not be doing work. Okay. So use the work energy theorem to calculate the velocity after 20 meters. Did they say anything about the starting velocity? So the initial velocity is 0. So the initial velocity is 0 meters per second. So the initial kinetic energy will be 0 joules. Okay, I don't have to calculate it. You know how to. You understand why it's 0. Okay. So I've got to start with this equation. W net equals delta EK. Or I can start with a half mv f squared minus a half mvi squared. But that will give me my mark. Okay. Now, for the W net, what do you want to do?
Get the W net.
Calculate friction.
We've got friction as 30, we've got applied force as 250.
The work done by the friction.
Work,
I was going to ask, you see, we calculated W net in the previous example.
yeah, but ignore the previous example.
Can't we
now.
use that value in this?
No, because, sorry for belaboring it, you need to work from scratch as though it's something new. Okay? So W net will be the work done by friction plus the work done by the applied force. Am I right with that? All right with that? Okay? So then, that is going to be a half mvf squared minus a half mvi squared. I already know that this is 0. Okay. So half times mass is 40, and this is the unknown thing. Okay. Now I need to work out this sentence.
Yes. We can take the fraction. We will say WFK equals to.
So it is 30 times 20 cos 180. And that one is 250 times 20 cos 30.
Now, so are they calculating V?
They're calculating the velocity, the final velocity.
It's 3.05 meters per.
Great, Josh.
Yes, but I already.
You already wrote it. Give them a chance, Josh. So what's this part equal to?
The x component of the force.
What's 250 times 20 cos 30? I'm not going the x component because I'm using cos 30 as the angle between the force and the displacement. I don't have to do components.
What's the answer for the first bit? Is it 3,780? The
Yeah.
answer for the first bit.
Yeah.
Comma 1, 3.
Yeah.
It's like Zibi said, we already have that answer
Yeah, yeah.
from a previous problem that we did.
We did it today.
Yes, I know. Sorry for boring you.
It's okay. And then a half of 40 is 20, so 20 VF equals to the 3,700 and
Okay, so I want to know what VF is.
we just square it.
We're going to root it,
Sorry, root it.
square root it. Right, Joshua, what did you get? 3 comma?
A 3,05 needs a second.
I did not get
What,
that.
13?
13,660.
13.
Yeah. 13.
Try again, Josh.
13 comma
How does
66.
What is that? Oh,
13,
13.6.
comma 66.
Yes,
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 I
divided by 20, then
How much?
you just square it.
Yep.
Right?
What did you say?
I root it.
No, I said most of it that, but then over 20 units. Because that you're dividing the displacement.
So it's 13.
Hi, you guys.
I don't know.
It's 13.
Come on.
Here's
Which
what-
one is it?
Here's what I did.
13,660.
Here's what I did. Where's my book? Okay. So I took that in.
Now what? What you
Divided by
13. Yeah. Okay. We also come on.
It's the same answer. It's the same answer.
You get
Yeah? If you do it this way, you get the same answer. You probably lose that answer. It's the same thing.
But his 3 is wrong.
Where is the...
It's 370.13 over 20. You're doing what you're doing, mate.
Where is that coming from? Where is that number coming from?
Infinite.
I want to see where it is.
Oh, okay. I don't know.
What did you get?
So I get 3,730.13
Yes.
for the work done.
Yes.
So we need to divide that by 20. And then we need to take, so it's a 186.51. You need to take the root of that. And you get 13.66. Josh, sorry, you made a mistake.
It's okay.
You need to fix up your calculator mistake. Or change the batteries on your cassette.
Yeah.
Right, number 3.
Wait, number done for the consecutive is the consecutive forces, conservative forces, and the WNC is the non-conservative forces, and the sum of energy is mechanical energy,
Yes.
and then the delta EK, which is the change in kinetic energy, is just the kinetic energy.
Yeah.
Okay.
Just the change in kinetic energy.
And then, what else? You see the WNC equals to the change of kinetic energy plus
No.
the change of...
Yeah, changing kinetic energy plus the change in potential energy.
That is based on the not...
This.
That. Okay.
Yeah.
Yes, ma'am.
Okay, who's reading next?
Siba.
I can...
Has to be the boys now.
I can read now.
Now, quickly, you can do the next one.
A trolley mass 2 kg is initially at rest at the bottom of the runway. It is pulled up the runway inclined at 25 degrees to the horizontal by a constant force of 100 newtons. The trolley experiences a constant frictional
Alphabetic.
force.
So your F applied is 100.
Yes, yes.
And the angle of the incline is 20.
25.
25. Okay?
The trolley experiences a constant frictional force of 50 newtons as it moves
50.
50
Yes, ma'am.
50.
So here we have a situation where there's an incline of 25 degrees. So that tells you there's a change in potential energy. So there will be a conservative work done. Gravity will do work on this. If there's a change in potential energy, then your gravitational force will do work on it. Are you alright with me? Saying that. So to draw this force diagram, there's an applied force. If applied, 100 newtons.
Yes, sir.
There's a friction, Fk, and
There's a perpendicular.
there's Fn, but it's 90 degrees to the incline, so it will not do work. There is the Fg, but the Fg's got a parallel component. The parallel component will pull it down the plane. Alright. Okay. What's next?
It moves 8 meters up the incline.
It moves 80 meters. 8 meters. So our delta x is 8. Okay. Anything else?
No. Then it says determine the network on the trolley.
Determine the net work on the trolley. Your? So I can go W net is delta EK, but I can also go W net is the work done by the conservative forces plus the work done by the non-conservative forces. So you're telling me that this equation is not on the data sheet?
No, ma'am.
Okay.
But it's an easy.
It's alright.
It's alright.
Okay. So I'm going to start off with that equation, and I'll say the work done by the conservative force is if G sine 25 times 8 times cos 180.
FG is.
Are you happy?
Yes, ma'am.
That will give me, the FG sine 25 will give me the parallel component. But let's do it. mg. So it's 2 times 9.8 sine 25 equals, do you want the equation in between?
It's negative 66.
No.
You don't want the equation in between. You don't want this. If G sine theta delta x cos theta.
Yes.
Okay. Plus. Now we've got the F applied. Am I right?
Yes, ma'am.
If applied delta x cos theta, so we add to this, what's it, 100? 100 times 8 times cos naught.
Yes.
And then there's still the friction. So it's plus Fk delta x cos theta. And that
FK is plus FK.
50 plus 50 times 8 cos 180. So the weight and the friction will do negative work on this object.
No. It shows a positive 2. 333.
Oh, I'm going off the screen again.
Let me, oh no.
Alright, can you get the value?
Sorry? Yeah. It is right. Yeah. 333.7.
Why do I get 5,02?
It's incorrect.
It's incorrect.
It's a Casio problem.
What other proof?
And what did you get?
333.
Yeah, that's also.
Yeah.
Damn, I feel like it's your
It's the operator.
How many marks is this?
I didn't know the whole
Okay. This has to be 8 marks.
Ma'am?
It has
Ma'am,
Yes.
would you advise us to like do as like one go, just like what we do right now? Or first calculate the conservative work done?
You can do them separately or you can do it all together in one step.
Times.
It's better to, but often what happens is, for example, people forget about the weight. You remember last year when you had to do Newton's laws? Go back to those and look at what you did wrong most often, because the same thing will happen here if you don't concentrate, if you don't sort that problem out of identifying all the forces that will do work. 333.73.
Yes, ma'am.
Okay, what's the next part, Buthe?
Determine the velocity of the trolley after moving 8 meters up the incline.
Okay, so they didn't give us a specific initial velocity, so I assume the initial velocity, or did they tell you?
Yes,
Yes, they told you. So there we have our equation, W net equals E K delta EK, and I've got the value for W net, it's 333.73. I know that the difference in the kinetic energy is a half mv vf squared minus a half mvi squared. This will be 0.
Yes.
So substituting the mass, so Vf will be
Is it just 3, 3?
Wait a minute.
She's 18 now.
Yes.
okay. Is that the end of that problem?
Yes, ma'am. 83? So, 27. So, ma'am, basically, ma'am, if you have to work out the velocity, you always go to the root of like f, W net equals to the delta, change in kinetic energy.
Unless we've got only conservative work done, then your change in kinetic energy is equal to your change in potential energy. Then you can go to that principle.
Yes, ma'am.
All right?
Calculate the acceleration. We don't need to, ma'am. They didn't ask that. Just
No, they don't ask you to calculate acceleration, they ask you to calculate velocity.
So we can go straight
Okay.
by saying, okay, sorry. Saying
Which path are you taking?
I'm taking the W net equals to E.
W net equals to the changing kinetic energy. Definitely.
Wait, why?
Because there is a change in kinetic energy, so that is the safest thing to do.
Why can't you use the W net equals to WC plus WNC? Or is it?
You're going to have to use that as well.
It's included.
Because this WC plus WNC equals the delta EK. You have to combine the two. Unless you want to determine the net force here, you can do it that way as well. So you can do it that way, or you could say F net delta x cos theta equals a half mvf squared minus a half mvi squared. The problem is, please don't say that the force is equal to the work, because that is also what happens often. Can I get the net force there?
You can.
I don't know that
You can.
Can I suggest another way? You see, we can take the same path as the, see the W net, yes, ma'am? No. The W net equals to the change of kinetic energy. Let's work out the work done of the friction force and also work done by the parallel force. And then be equal to the EK, which we need EK, right?
You need
Yes.
Vf.
And then I'm going to take the EK and then we're going to put it, we're going to say the change of kinetic energy equals to a half of mv yes.
So you're going to put this part in here.
Yes.
Okay, I'm happy.
Okay.
You see, when you're answering this question in a test, then you're under stress. So you have to be comfortable with your way of thinking about it. If I look at the situation, I just want to go work, energy. But it would be the same amount of work to get the net force by only looking at the forces, because you're comfortable with Newton's second law, I hope, and then go that far, and then start here. So WC would be the FG parallel, so it's FG sine theta. Do I have this angle? Oh, so we have the angle, so that is not a problem. Thank you. Then, delta x cos theta, that would be 1, cos of 0, that will be 1, plus, now the MC is the kinetic friction, so it's Fk delta x cos theta, which is 180, equals a half mvf squared minus a half mvi squared. The vi is not 0 in this case.
It is
4. Yeah. This is 60 times 9.8 sine 30 times 50 cos 0 plus 50 times 50 cos 180 equals a half times 60 Vf squared minus a half times 64 squared. Right, so we get
No, wait.
20.56.
Yes.
VF is 20.56 meters per second. Did you get it?
Yes, ma'am.
Okay, so the common mistakes here is that people forget to square the velocity, and they also forget to root the final answer, to square root the answer. Those are the common mistakes. And they don't know which equation to use. So you need to go and work through exam problems where they put you in different situations, and have your summary of equations with you. Have this sheet with you so you can choose your situation. Right. Number
Right, if you thought that the motion would be like a parabolic.
You complicate it too much. Okay, read the question. So from point A, okay,
It's a parabola.
okay.
It's on a hill, man.
What now?
It is on ice-covered hills.
Yeah.
Oh! Okay. So it's something like this.
It's like a cosine.
So that's point A, and this is point B, and the height there is 20 meters above B. Like that.
The graph.
Alright, Scotties.
F of x is equal to
Okay,
cosine.
we got it. Joshua, carry on.
It slides up to point C, reaching a speed of 10 meters per second. So Vf is 10, and then let's see. If friction is negligible, calculate the velocity of the block at B.
So that means that there's no friction.
The V is.
Yeah, there's no friction.
And what's the initial velocity of at A0?
It was released from the earth point. It doesn't
It's
specify.
released. So VI there is 0. Now it is important to realize that there's no friction here. So what is making it slide down?
The gravity.
The gravity. And we know that gravity is a non-conservative force.
It's conservative.
Sorry man, my humble apology. It's a conservative force. Okay. But they want us to calculate velocity. So can I use this equation?
Yes, you can.
There's no velocity in that equation. So we can't use that equation. But today, earlier in class, we said that the work done by the non-conservative force is 0.
Yes.
And we got to the total initial mechanical energy equals the total final mechanical energy.
Yeah.
So will you be comfortable if I use WNC will be 0 because there are no friction or applied force or anything like that. It's only the gravitational force that makes this thing move. So WNC is 0, so I can use 0 equals delta EK plus delta EP. I can use that. Because this equation is on the data sheet. Use it. Because then for sure you will not make a mistake.
Oh, we can use it because, man, you see the delta EP? Because it's high, so it has potential energy. Alright.
There's a change in kinetic energy as well as a change in potential energy.
Yes.
So the best advice I can give you is to say that use WNC, because that's 0. And this would be a half mvf squared minus a half mvi squared, which is 0, plus mghf minus mghi.
Please switch off the lights. I like the dark.
So that's the
Alright?
Thank you.
what is MGH?
It's the potential energy.
Mass, gravity, and height.
Yes.
And the gravity is
Height is gravity.
So that's 0. This is a half times, what was the mass of that thing?
10.
Really?
A 10 kg, yes ma'am.
But I don't, okay, let's substitute it, let's not. But you don't have to, you don't need the mass, am I right?
Can you factor them all out?
Yes, because it's a common factor.
I'm just going to use it.
Yeah, let's
Yeah.
use it anyway.
Yeah, let's use it.
It's safer.
I'm just saying, like in grade 10, I showed you one where you don't need the mass because it's a common factor everywhere. So if they don't give you the mass of the object that's going down this roller coaster, don't be thrown by saying, oh, I can't calculate it because I haven't got the mass. Because mass is common here in all the terms. Yes. Vf is the one we want. Vi is 0, so the kinetic energy will be 0. Plus 10 times 9.8 times 20. And the initial height. So,
20.
no man, I'm wrong. This is 0. Times 0. So that the final height above above B is 0. Minus 10 times 9.8 times 20. It's just to substitute the height in the right place. It's final minus initial. Now off the oh no, not off the screen.
Ma'am, with height involved, we can always look at the equation with the change in potential energy, right?
Yeah, but then you're ignoring the kinetic energies change. Then you won't be able to use it to calculate kinetic energy.
Vf is equal to.
JB, give them a chance.
I was just checking.
Man, why do you have to write it down?
You still have to get it on your own calculator. Don't copy it. Sorry. Was that all in that question? The only thing?
Vertical height at point C.
Oh.
How the hell are you
You use the same principle.
It's the same equation now.
It's exactly the same principle. The work done by the non-conservative force is 0, so you use exactly the
Oh,
same.
wait, the VF is low. 10.
You know what the VF is? It's 10. You don't know what the height is at sea, so you calculate the height at sea. Can I take this out?
Yes.
Okay, so the WNC stays naught. The change in kinetic energy stays that. The change in mechanical and potential energy stays that. Now, I'm going to use the values that they've got for C now. The height, they want height, not V. Okay, so it would be a half times, what was it? 10.
Yes, ma'am.
Half times 10, and that's 10 squared for final velocity at C. The initial velocity at A is still 0. I don't have to use B. I could use B.
Now what are we doing? What are we doing?
We're calculating this height
Then why is A in the equation?
because I'm using that and this. That's all. You can use B and C, but you can also use A and C. So they want this height. You're welcome to use B and C's values.
Yes.
Okay? Plus 10 times 9.8. Now it's HF that I want to calculate. Minus 10 times 9.8 times 20 was the initial height.
Ma'am, can I use, see, for example, if I take the B and C part, can I take the B as my initial velocity for C?
Yes.
Okay.
So your equation would look like this. Naught is a half times 10 times 10 squared minus a half times 10. What was that velocity? I wiped it out.
Velocity?
19.8.
Yes, ma'am.
19.8 squared plus, I'm going to shorten this now, 98 HF minus naught.
Yes.
Ma'am, don't you swap the 10 square and the 19.8 square since it's final?
No, it's final minus initial. It's going from B to C.
Can we all just come? No. Divider.
The competition is on.
What did you get? 20.
Can't be 20.
It can't be.
Are you in, guys?
40.9. Yeah.
You can need to hear the answer at some point or another. Like,
Let's just calculate it.
it's not that deep.
What did you get?
14,9. I did get that.
Way.
I got that. Look at us. Can we all just come down?
They look rather calm to me.
No. You haven't seen us play 30 seconds.
Oh, man.
There's no friction, so the principle of conservation of mechanical energy applies. You could go like we did at the previous one, or you could say that the total initial mechanical energy equals the total final mechanical energy. I'm deliberately doing it this way now to show you there is another way. It comes from this equation where WNC will be 0. So my initial mechanical energy would be the half MVI squared plus MGHI. Are you with me?
Yes, sir.
And that would be equal to a half mvf squared plus mghf. Technically, it's the same thing. I just didn't start off by saying that WNC is 0.
But you should do that.
You can do that. You can do that. If you want to follow the same pattern as the previous one, you are welcome to do that. Okay, but I know, because there are no non-conservative forces, mechanical energy is conserved. So I can work from that point. Okay. So it's a half times. Now you can see M is the same everywhere. So why multiply by 1,000? You can scratch that. It's 1,000, but there's 1,000 in every term. So I'm a lazy person. I'm going to scratch it. The I is 0. Plus 9.8 times 40 equals a half times. Now they want us to get the VF, and I'm going to go for B squared. Plus the height there is 0 at B.
Did you mix it up?
She
Why?
cancelled the masses.
Mom, what did you do?
All of the masses are common.
I removed the mass as a common factor.
Why is the MGH with MVI? What's the
No, look, it's the
It
total
goes from
account-
A to B. The height at B is 0.
It's the total. Initial mechanical energy and the finals. So it's the potential and kinetic added together. Potential and kinetic added together.
The 0 is the initial velocity at A.
Oh,
Okay.
And this 0 is the final height at B.
sorry.
What's the answer?
I'm so confused. How did it get here?
And I didn't use that formula.
I use the principle of conservation of mechanical energy, where the total initial mechanical energy equals the total final mechanical energy.
You use the mechanical energy between point A and point B.
Yes, because I want the speed at point B.
Oh, we're doing B first.
Yes, we're doing A, B.
Right. Do we have an answer, Zibi?
28.
Oh my goodness.
What answer about B?
Okay. Then they want the speed at C as well. Now you need to decide: are you using A and C or B and C? B and C.
Yes.
A and C is so safe.
But we just got B. Let's test it.
The thing is, if your B's answer is wrong, your C's answer is also going to be
A
wrong.
and C.
Okay, let's do both.
No, you can do both.
You can do both.
You're full of energy. So, what is the velocity at C is the question.
Okay, can we please do B?
Alright, fine, do B. But I hope your B's answer is right.
It's
So the initial kinetic energy at B is a half mvb squared plus mgh at B, which is 0, okay, equals a half mvc squared plus mghc. Okay, am I still on? I just made it. Now, you want me to do it without cancelling the mass? So I'll have to start here. 1/2 times 1,000 times that 28 squared plus, I don't have to substitute that because it's 0.
Yes.
Plus 0 is the height at B equals 1/2 times 1,000, actually 500, VC squared plus 1,000 times 9.8 times 15. What is VC?
That's what it's all
I'm using A.
Me too, Nano.
Same.
Yeah.
I'm looking at the trail.
It must be less than 28.
Yes, ma'am. Just it is.
No, wait.
Whoa.
Oh, come on, guys.
Sangya? Shush. We're gonna fight.
Oh.
Boxing match outside.
No.
The answer is.
You're not fun.
Joshua.
Like that.
I answered.
I'm not making this word. I refuse.
Is it just a 25?
I refuse.
Yes, I got that. And I used A. And I got that. I used A.
My thing is loading. Yeah, it's doing it.
Now I should also get this now. Don't look at it, don't look at it. Don't look
Oh,
at
I love you. See, now, are you also using that function that JB is using? Where you build the equation and then the calculator calculates it.
Oh, no.
Don't you know? Hey, teach Sinalo how to do it, but go slow
I
now.
want to buy this silver